Hello everyone, my name is Nadav and I will present our work, a statistical model for quantifying the needed duration of social distancing for the COVID-19 pandemic. As I was quarantined and social distancing, as most of us were, my colleagues and I wondered about two things. First, is there a mathematical way to quantify the effect of social distancing at stopping the spread of COVID-19? And second, how long will social distancing be a part of our lives?
We looked through the literature and saw that a paper published in Science by Kistler et al. Did just that. They used a variation of the SEIR model, a classical, well-known epidemiological model, and estimated, under the assumptions of no seasonality, which today seems to be a decent assumption, permanent immunity, and no vaccine, when would social distancing end? Now, this is a paper that made quite a lot of noise in the media and caused quite a lot of panic. And the reason is that it predicts social distancing to remain in our lives until somewhere after 2023. In fact, they also studied other scenarios, such as one where the virus is seasonal or that immunity is not permanent, and 2023 was their most optimistic forecast. Now, one limitation of their approach was that they used data from other coronaviruses, such as SARS and MERS, in order to estimate the parameters of the model, as they did not have enough data from COVID-19 at that time. So what we wanted to do was to apply this model using the same assumptions on COVID-19 historical data and see whether we get similar results.
And so we did. We applied that model to historical data from 6 different countries that had a sufficient amount of cases where one limitation of the model is that we can only use data from a time before social distancing has started. Once we did that, the first thing we've noticed was that there are many sets of parameters that provide an excellent fit for historical data, yet offer a very different future, as you can see in this figure. For example, on data from Spain, one set of parameter would estimate social distancing to end around August 2020, 1 month from today, and another set to September 2022. And you can see that there's a huge gap between these two predictions. Now, since both these sets of parameters provide an excellent fit for historical data, there is no real way to distinguish which is more accurate in predicting when social distancing will end.
One way to solve this is to regularize our parameters by jointly fitting several countries instead of a heterogeneous model where each country is fitted separately. Intuitively, though many sets of parameters may provide a good fit for a single country, the more countries we fit jointly, fewer parameters would provide a good fit for historical data. To put this in a more formal form, we developed a Bayesian hierarchical model where each country has different parameters, yet they all belong to some shared distribution with a joint global parameters. Once we do that and fit these global parameters, we can draw samples from the shared posterior predictive distribution and acquire a distribution for the end of social distancing, as you can see here in this figure. In our work, we predict social distancing to end sometime between July 2020, which is now, to July 2021, when the median is October 2020. And let us remind ourselves that this model is limited by the assumptions of no seasonality, permanent immunity, and no vaccine, all of which may dramatically affect our distribution. Breaking these assumptions of no seasonality and permanent immunity would likely lead to social distancing staying with us much longer. A vaccine, on the other hand, would probably help control the pandemic and end social distancing sooner. We also assume that social distancing restrictions are applied and lifted according to the number of current cases and not due to other forces such as politics, economics, etc. It is important to emphasize that though our model is restricted by these assumptions, our approach is not limited to COVID-19 and can be applied to any pandemic. Now, to finish with an anecdote, I would like to share that at the end of April, when we first got these results, that social distancing will end sometimes within the next year, and compared it with Kistler's estimating 2023, we considered it very optimistic. However, a month later, when we submitted it to this conference, we found it very pessimistic since the general vibe, at least in Los Angeles, was that COVID-19 is just about to disappear. And yet again, a couple of months have passed, the number of cases is rising, and we have gone a full circle back to consider it as an optimistic prediction once again, showing the importance of uncertainty in scientific prediction. At this point, I would like to thank the organizer of Health Day at KDD 20 for giving us the stage to present our work and to my colleagues from the Department of Computational Medicine and Computer Science at UCLA, Boyang Fu, Professor Eran Halperin, and Professor Sriram Sankararaman, who have worked on this project along with me. I hope you found this video informative and engaging. For any questions, feel free to contact me via email, Twitter, or any other social media. Thank you for listening, stay safe, and goodbye.